All right. Okay, so what we're doing, starting off today with. Yeah. Oh, I just peaked it to red. Sorry, VOD watchers.
You can probably just restart the recording if you want to.
No, I'm gonna scream into the recording. It's funny. All right. Okay, so is Netbird connected? Hold up. Give me a second. Okay, I have no idea how the networking works on Akil's computer, so apologies for the brief. Are you freaking kidding me? Are you serious right now? Okay, let me think of like the fastest way I can check. Just Control C. FN's? Oh, he remaps control to FN. No. Sorry, okay, so that works. Okay, oh wait, no, I have an SSH key, so that wouldn't work. Wait a second. I gotta check the back end because DNS is not. Okay, that's 168. Forgive the brief interruption as I figure out how to work the VPN. What is the? Okay, perfect. DNS doesn't work on your range, on your Netbird, so I had to go around. Okay, all right. Where are we? Okay, talking through assignment 4. How do everyone feel about assignment 4? Because I read through pretty much like all of your reports by now, and I mean it seems like, well, not that people did badly. It's just like people put a lot of work into what I was assuming it wouldn't be as much work. How do we feel? Just like throw out some comments. I want to hear.
So many rabbit holes.
Interesting. Anyone else want to complain or have anything? Feel free to complain. Like your feed, we care about your feedback. If you say like this is bullshit. Oh. I shouldn't swear. Well, if you found something was like not worth your time, or you think that it wasn't fair, like let us know. Now or later.
I think it was hard, but I think it was fair. Just like first getting into the system and then learning what to do was one thing. Yeah, I just think it's.
And anyone else? Anyone disagree with that assessment?
The hardest part was just like trying to figure out what's at the CVEs for like how to like first find like an actual exploit for a CV, and then figuring out how to like get it actually compliant.
Yeah, I did read a lot of. There was certain exploits were much harder to use. So I mean, the ones I'll use will be the ones I found that happen to be the easiest to use. Of course. I didn't require you to use the easiest one to use. It was just, if you got it working, that's fine. But I understand that it was also a struggle to get certain exploits working. All right, let's show off everything that I hoped you would find. All right, let's start. First one off, pretty much everyone got this. It was the SSH key. Let me see if it works through. Firefox School is the one that's cool, right? Okay. I think. Let me see if I can access it here. Okay, yeah. You found that there was a website running on port 80 standard, and there was also a git Git repo on there. If you go and looked around, I don't know who made hello. I think getTadmin's the default one. Ethan, were you the one that made hello? Okay, never mind then. You'll see that 3 weeks ago you adjust. If you look through the change log, you'll see that I left a SSH private key in there, and then you had to guess at what the username was. So let's see. I have the key file already set up here. So I'll just like say a user. So I think a lot of people try like getTadmin at 10.3.10.123, and the way you use it, -i, and then just use the path to the file. Of course, if you saw something like this, it asks for a password prompt. That means that something went wrong with it. Some people had issues with, the permissions were set wrong on SSH, or the username was wrong. If you tried the username dev, that would give you access. That would just get you in immediately with no password. So that was the first method. The easier method that was worth less points, and then the rest of the ones I scored. Go ahead. Yeah, it was. So yes, the password for the dev account was just password. I mainly set it out of laziness, and I was just seeing like if anyone would catch that. But the SSH key is the expected method. The password thing was just like a fun trolley trick that I was just seeing like, would anyone catch it? But it wasn't. But if you used the SSH key, you got full points for that specific exploit. Okay.
Jason, did you get a voicemail when you called last time? Because I did.
Last time I called, I got directly patched through.
Okay, well,
So-
we're not getting anyone.
Okay, we'll see. Okay. Okay, so that's the first initial access chain. The second initial access chain was to the user gkerman, and that was a bit of a more complicated chain, which each of the steps scoring points. So first thing you want to do is, okay, I'll nmap the box again. And what should come up is FTP. A lot of people, I would recommend when you're trying to pen test new services, I would recommend you look through a guide of how to do it, because there could be 9,000 different things wrong with it. I tried to make it the most, the most low-hanging fruit exploits. But, if you're just saying, I have this new service, I have no idea how to approach it, I know it exists, what things should I try? And what I usually go up is just like start looking through like FTP methodology. And it looks like this first result, I like hacktricks.wiki. So it will tell you a bunch of things that you should try for FTP. And among one of them is a thing called unauthenticated, anonymous login. So FTP public share is just a program that shares files. There are use cases for when you just want people to just be able to grab something, like a public file share. Maybe you're hosting things people want to download, and you don't necessarily want them, you don't need an account to download something that you want to make freely available. I always recommend is try the user anonymous. So I'm gonna try that. Anonymous.
Discord also stopped streaming?
Go.
Wait.
Yeah.
Pause.
Pause the recording.
Yeah.
Leak his DMs. Sorry. Okay. FTP. Okay, so you can page. Oh, this button. If you just FTP to 10.x.10.123, we'll ask for a username. If you try anonymous, login failed. So anonymous doesn't work. Is there any other ones? There's anonymous. Looks like they formatted this wrong, but again, here's the convention: username, password. So you should try anonymous, username, anonymous, password, anonymous. I think this is supposed to be like this is like a formatting issue, but it should be anonymous, no password, or FTP, no password. Tried anonymous, doesn't work. What about user FTP? And it looks like we're immediately in. See if there's any files. There are 3 files in there that you could download and read. One is announcements, one is onboarding, one's placeholder. I'm just gonna get all of them. Let me see if I can pull the original ones from. See if there's anything sensitive I want redacted from this. No, not really. Actually, okay. So I'll pull. So instead of downloading the PDFs, I'm just gonna grab the Google Doc that I already. Grab the original Google Doc that I had done for plan. Can you log in? Thank you. Pausing for that too. Why is it still on cast?
No, it's because of the. Hang on.
Linux users trying to do like literally anything. All right. Okay. So here are the documents in their original form as Google Docs. One was this new employee onboarding. There's this. There was given a hint of username, first initial, last name, and a password, a default password. The scenario I was giving is, you have a new user coming in and maybe your company has a standard default password they give just to speed things up. You expect them to change the password afterward, but for whatever reason, this new user hasn't. That was the scenario I was trying to dream up. Yeah, this is just like fluff. And of course, and also this announcement that was meant to contain information that says, there's a website. We want new users to be able to access the website, and you can access the web root with all the web pages through some kind of share. Users will receive temporary access, then we'll clean it up, but evidently that did not happen in this case. Oops. This is not the final rubric. Okay. So where can we go from here? Well, we know that there's a standard username format, and we know that there's a password we can try. So, what other, is there anything on the website that could give us information for what the usernames could be? And that was the intention of this main site. The About Us, Kerbal Space Program, I've teed in a bunch of astronauts, and then I was hoping, you would go through all of them, generate from this information, generate a word list of first initial, last name, and then try and brute force the password against FTP or SSH. So in this case, I'm going to skip straight to the solution. It's going to be, let's see, so Jay Hansen's going to be the user as people found. So let's see, Jay Hansen at 123. I realize I have to actually type the password that I cooked up. So I did not. Oh, Fly Dream. And a very interesting thing happens when you try to SSH into Jay Hansen's account. It pretty much boots you out immediately. So I do want to emphasize that Jay Hansen trying to SSH boots you out. That's not shell access because you cannot do anything. I can't do stuff on the shell as Jay Hansen. So maybe that's not the first foothold we're looking for. But let's try the credentials on FTP to see if that works. And it looks like I do have credentials. So this is a thing that might happen, is that you have users that may not be able to log in on the system itself, but have access to some other services. So in this case, now that you have some access, let's see what files are in here. And it looks like we have, we can see this looks pretty much like the web pages that are in the main site. Pay no attention to the man behind the curtain. One interesting thing you could do that I did not originally anticipate is that you could actually move around and do things from this FTP it's not technically a shell, but you could look around at files. So I mean, you could go cd .. and you could look around. You could look around stuff, phone files. You could even pretty much find all the user name of the user accounts from here. Is my charger compatible with yours?
Yes.
Okay, plug it in.
Oh, it's my laptop?
Yeah, you're at
Oh,
18%.
wow. Okay.
So that's an interesting way of kind of moving around and being able to discover more stuff on the system. What I had hoped has happened was you see a website, you have web pages, you realize that these web pages, you can put stuff into the web server and see like, would a web shell work? What ended up happening for most people is when you were poking around the system, you found this user called local user, which to give you a behind the scenes was the account I used to set up all the initial account I used to set up all the just this entire system. And if you look in here, it gives you like 500 different clues as to what the kind of things that were going on behind the scenes of the assignment. And you did see that there was a funny file called payload.php. Oops. I think I can cat. No, I cannot cat.
Get it.
That's like a lot of work. I don't want to. But payload.php is a web shell, and probably from there people figured out that if I just put some kind of web shell file into the web root, what happens if I go to it in my browser? So, I think. Let me see if this works. Okay, it does work. In this case, I've already set it. There was an interesting interaction where if you just copied it on there using Jay Hansen's default credentials, it wouldn't work because you didn't have the right permissions. The web server runs as a user called www-data. That's like automatic setup when you install it, but it is not running as a Jay Hansen user. So initially when you put the payload.php file, it wouldn't have the right permissions to run because the web server is like, I'm not in the user, I don't have rewrite, execute. I think it was, I don't remember which permissions were needed, but I got lazy, so I just gave it all the permissions. And after modifying the permissions, if you just navigate to the web shell in here. Oh, that's right. I think I have it set up to communicate on port 9001. And now you have a bit of a web shell. It's more access than the FTP. I scored it separately from FTP because FTP you can look around at stuff, but there's not much of an ability to run commands. Once you have this web shell, you do have an ability to run actual commands. You can run linps, but I don't know if it's like a little limited. This is not the same. It does not have as much features as an SSH shell. I think like if you try using up, down, arrows, tab, autocomplete, does not have any of those fancy features, but you can run some basic commands. But what I was hoping to happen is people would start looking around the system, see is there anything interesting in the home folder. And if you look at Jay Hansen, nothing really going on. But if you go into the gkerman user, I'm in the wrong folder, my bad. There we go. You'd see two very interesting files, a kind of todo.txt and a folder called WordPress. If you look at todo.txt, it gives you a very interesting hints as to what the next steps could be. There is one website migration checklist, insert database credentials. That's always probably interesting to look at. And interesting patch notes with some vague message talking about an exploit using Python 3.10, but this computer not having Python 3.10, but Python 3.8 installed. So some kind of exploit works, but it needs like a specific version. This was hoping to be a hint as for when you start doing privilege escalation. But in the meantime, let's try and find database credentials. WordPress, if you look at it, you could also, go Google like, oh, WordPress, where does it store database credentials? And you'll probably find a file called wp-config.php. And this, okay, so it doesn't like, oh, I just killed the shell. Give me a second. Cat, let me see how to remember this. /home/gkerman, kerman/WordPress, p-config.php, grep it for db. Oh. I can't use the up arrow. db. Oh, it doesn't like it. I'm just gonna copy paste this. You map control the function,
Yeah.
yes. Okay. I think we can scroll up in tmux, but I don't think the shell likes it. But if you downloaded it, there was specific credentials, gkerman credentials, and you see that gkerman's user, what happens, is it possible that this user reused those credentials for logging in? In that case, 3.10.123, I'm just gonna pull it from my planning document. I think this was the password that was here. In this case, this is a much nicer shell than one before, right? It has tab auto-completion, it has up, down. Well, I don't have anything stored right now, so there's nothing really can run. But from here, you have two separate users that you could break into, and that was counted as initial access. So any questions about the kind of initial access steps you found so far? So I guess go into detail about the scoring. I scored 5 things from my rubric. It's finding the SSH key, finding anonymous access in FTP, finding the J. Hansen user logging into there, using a web shell on the web server, and then finding the credentials for gkerman. There could have been you could have used any combinations to do the steps to do the privilege escalation, but I was hoping you'd find all 5 of those vulnerabilities. I will say that for reporting and scoring purposes, let's see, what are some of the most missed points? Two of the things I noted that people missed points on. One was people were accessing the anonymous FTP share, but they're saying, oh, I just logged into FTP and found these files. And then there's like a screenshot, and I could see like, oh, these documents probably came from the anonymous file share, but you didn't specifically say, I logged in via anonymous file share. They said, I logged in via FTP. Because there are 2 separate ways to log into FTP, one anonymous, one not anonymous, we're looking for that specific wording of just like, I logged in via anonymous, which most people did right. But we will, if you see that in your scoring comments, that's one thing that got missed. A second thing that people missed was people were, how did you discover the J. Hansen username? We saw in people's reports that people just say like, oh, I did these steps, found the key, logged into FTP. Oh yeah, by the way, I logged into J. Hansen using this password I found. I understand where your logic comes. We could see the reasoning where the password came from. I mean, it's from the document I saw in your reports. You had a screenshot. You were looking at the document. But where did the username J. Hansen came from? We're expecting people to either say, I found it on the website in some form, or there was a very interesting interaction with one of the services I forgot to disable before deploying that ended up helping people, which was SMB. Which, if you look at the Nmap scan, there's SMB. It wasn't that vulnerable, but there was certain things you could do to it that could help you. Let me just show that off real quick. So SMB is kind of a file sharing thing. It's not like it works a little differently from FTP, but one useful thing you could do is try and enumerate users via SMB. There weren't any like explicit vulnerabilities put to it. I was thinking, oh, is there a vulnerability I can put into it? Ended up not finding any, but I just left it open. because mainly I forgot. But if, some people were able to use it in a way that helped them. So I think if you use the tool enum for Linux, which is a tool that scans SMB, I think, yeah, found SAD. It would actually, if you go through, it would actually be able to enumerate the usernames with pretty much no access. So, you didn't have to FTP in and dig around to find the usernames. You didn't have to use the OSINT. There was a way to, let me see. Power users, this is Windows, but I think in a quick second we'll see all the usernames of the actual users on the computer show up because I left SMB open. Yeah, there we go. Local user, dev, G. Kerman, J. Hansen. No other ones show up. So that was another way you could have discovered the username J. Hansen. But if you just said, oh, I used the username J. Hansen, the first question me, Ethan, Akil always asks is, where? Right? Are you pulling these usernames from thin air, or do you have a specific justification to use it? I would have accepted it's like, oh, I noticed you use astronaut names, so I generated a word list of like the 1,000 most famous astronauts, and I tried them again. Like, that's something. But if you just said, oh, Jay Hansen, I used the password on the user. Huh? All right. That's initial access. Time check.
How much longer do you think it will take?
I'll do like quick, maybe like 10 minutes. Okay. All right, on to the privilege escalation. So privilege escalation, there was quite a lot of methods, quite more methods than I inserted because I decided to use a really old version of Linux. So let me just SSH ID. Just go from here. And I already have linpiece set up here, so we can just run it. Linpiece does give a lot of information, but I think if you just looked at the 95% of vector vulnerabilities, you would be able to find some pretty easy ones you could exploit. So I'm going to... I do remember. Oh. Bruh. Hello?
What's up?
I'm hitting tab autocomplete and I'm not getting tab autocomplete. ID tab bruh. Okay. Okay. It's a lot of data. I'm not going to, I guess I don't necessarily want to show you like, oh, I'm going to look through everything. I'm just show you the ones I put in deliberately. One of them was alluded to in the local user. Local user directory. You see that there's a, why is there a specific version of sudo in this user? So, I mean, if I go and look it up, the pseudo vulnerability. Okay, this is not.
You can Google if you want.
Yeah, I think sudo 1.8.31 vulnerability. DuckDuckGo has AI now. Whoa. So very interesting. There is a critical vulnerability that allows unprivileged users to gain root privilege for a heap-based overflow. You can find that it was vulnerable, and from there you can use some kind of escalation. I know some of the exploits on GitHub were using C, and because I was using, let me see what version of Ubuntu this is. This is Ubuntu 2004. So this is Ubuntu from 2020. If you try to, there's no GCC on this, so if you try to build it on your computer and then move it over, I saw that there were some issues with like, the C library on Linux on your computer is too new. This exploit will work. There were workarounds, but the easier workaround was the password for dev is password. The easier workaround is there were exploits that did make use of, I believe, Linux. So let's see which one I found. I'll just go on GitHub. If you look up the name of the exploit, this is one of the special exploits vulnerabilities that get a cool name. It's called Baron Samedit. And there was one that you could run with Python. Python, yeah. So if you just run this Python script, Python 3, gives you the £, who am I? That is definitely one way to find it. And this is something you could have picked up with linps. All right. Other ones you could have exploited were the very funny ones that dropped like literally the week before we made this assignment. There was copy fail. There was, what's the other one called? Dirty frag. Yeah, you could have run both of those. They would have given you root as well. I know some people found one called like overlay file system. There are just like a lot of CVEs with existing code that you could have chosen, choose any two, choose more, whatever to run. And it's just a matter of, is there an exploit that I can use more easily or less easily and whatnot. Okay. And then the final one, the one that I alluded to that was kind of extra credit because I wasn't sure how easy it would be for people to find, is there is a very interesting thing running in cron. So I don't know if linps is going to show it in time. I don't know why this window is open. It might not even be useful. But if you go to var backups, there is a very interesting file here. It is a file called backupscript.sh. It has very open permissions, so anyone can read, write, and execute it. And I believe, actually, I'll just use the Python 3 exploits, this one, cron tab -e. I think this works. Oh, you can't do it from here. Cron tab list. Cron tab list. Big if true. Cron tab -L. Interesting. It's not showing up in here. Essentially, the root user would run the script. The root user would run this backupscript.sh. Backup script. It would run this regularly, and you were able to insert code to make it root user do whatever you wanted. Open a shell, give you admin privileges. I know a very common one we saw was people would make a copy of bash called /temp/root bash, and then just run it with the set UID bit, and so you could give yourself privileges of the owner, which would be root. So that was a way that you could have exploited. Those were the main three ways you could exploit. One was Baron Samedit. That was deliberately like, let me install an old unpatched software package. Two was kernel vulnerability, so I'm running a really old version of Ubuntu, and there's probably a jillion different vulnerabilities that was in there. And then third one was cron job. So people ended up finding all of them, which all of them, and then some more, which pleasantly surprised. But one thing I want to note about the assignment that a lot of people and I'm afraid to say like probably most people lost points on was this specific clause. Assignments. This bullet point. I thought to leave this bullet point, leave no trace when you are done, refrain from taking any action that would cause damage or disruption, document exploit use, and cleanup of any artifacts. We ended up so this is our philosophy for asking this. When you are a professional pen tester, people do not want you to brick their systems. And if you end up leaving it in a worse state than it was before, they're going to be pretty pissed off at you. So, if you leave, you break into a user and you leave exploit code on their user account, someone's going to go and use it. It's like, what is this? And then it's like suddenly they have root over the system. Or if you insert code into the backup script runs every 5 minutes. You can delete the files, like say, oh, I make a copy of bash but give it root privileges. You can delete that root file, but that script runs every 5 minutes. It's just going to be back in the next 5 minutes. Let's see, what else? And there were some, let's see. So we really wanted to emphasize to people that you need to clean up after yourself. I know that the wording might have been like a little vaguer than I would have liked, but emphasis is you should clean up after yourself, and that's where most people ended up losing points on. One thing we penalized very heavily was the destruction of the backup script. So some people, when they were modifying the backup script, they would say, overwrite the backup script completely. This code, like replace the entire file with something that gives you root perms, and maybe clean up, maybe not cleaned up. That's the one we penalize the most. If you are, if you're hired to a company and you end up blowing up their backup system and replacing it with vulnerable code, code that like generates a shell every 5 minutes, root shell every 5 minutes, it's not, someone's going to get hauled before board of inquiry, and I don't know. So that's something we want to emphasize. I know that the penalties may seem harsh, but we wanted to balance just as equally doing the exploit and doing it in a way that maintains the integrity of the system afterward, whether that means like restoring the script from the backup, deleting exploit code used, or for, in the case of like the copy fail exploit, you need to reboot the system if you use copy fail, because if you don't reboot it, if anytime you run the vulnerable binary targeted, which was SU, every time you run SU, it would just get you into a root shell without asking for a password. Normally, it's supposed to ask for a password. The exploit kind of bypasses it. But if only a reboot is able to clear it out so it restores normal function.
Can't we use the base table document instead?
Yeah, that's for dirty frag. So yeah, that is a documented way of remediating it. So that counts as cleanup, yes. Yeah, all of this is just to emphasize cleanup. When you're doing real pen testing, cleanup is just as important as actually doing it. I know, like, when you go out and do practice labs on TryHackMe, it's like, you're here to learn the exploit. We here want to balance this kind of learning with also professional expectations. So, if when the grades come out and say like, hey, this is, and it's like, feels like, oh, this is cringe, this got penalized way too heavily, know that our philosophy was to balance exploiting and cleanup just as equally. Okay, that's pretty much all I have for assignment 4. I think, I guess I'll just find really quick, because some people weren't able to find it. Let's see, dirt, copy, fail, Python 3.8. The hint was like you would find I think a lot of people made modifications of copy fail, but it didn't require Python 3.10, Python 3.8. Splice, use a newer. This is crappy. This is crappy vibe coded. Okay. You can go on GitHub and look specifically for things that work with Python 3.8. Know that it was exploitable. Okay. If you have any more questions about the assignment, I'm happy to take questions.
I'd like to point out that there's a whole big API page on Wiki.
So I'm still investigating it. The API is not vulnerable. The API is an intended function for, I think, accessing JWT. It's like it has deliberate functionality. It's not documented very well, but it is not. It is feature, and not as vulnerable as you may expect it to be. I did a lot of research into looking into it. So, all right. Any more questions about the assignment? All right. Grades for it should drop sometime this week. We're making sure that grading is fair, and if you have any questions, talk to us about it. All right. Thank you.
All right. Let's get into the new content. So, as a refresher from last week's lecture, we left off when we were talking about config files on services. So when you're on Linux and you have services running on a system, you have config files that exist usually in the /etc folder. That's a general folder, the directory where config files for individual services will be held. So for example, for FTP, if you go to /etc/vsftpd.conf, that's where you can configure settings for FTP. Everything in Unix is a file. That's the general philosophy of the Unix scheme for operating systems. And so config files are used in order to outline a service's operation. So at the end of last lecture, we were taking a look at the vsftpd config file that I had on a system. We can do this exercise again. Look through this, work with your neighbor, find out what looks like terrible in here, like what looks really suspicious or malicious or vulnerable.
You said work with your partner. Research. No. How much power do you have?
53.
Okay, I'm gonna hijack it. Do you want me to break out your charger?
No, it's okay. Actually.
Okay, I can set up for you.
All right, any thoughts? Yeah, go ahead.
Is that anonymous upload directories?
Yeah, so we see anonymous upload enable equals yes, anonymous enable is yes. Yeah, so, and also they can create directories. And so we see this config file where it looks like people are able to log in as an anonymous user and make a lot of changes that they should not be able to do. And we can try testing the service as well. So let me close out of this container. So what was the IP address of this system? This was 10.0.3.38. So I can try FTPing to 10.0.3.38. And after, okay, there we go. I'm going to try logging in as anonymous. No password. And I'm logged in. It says login successful. We can try looking at what files are here. We said that there's this like hello file, upload file, but we're able to get in and we're probably able to also write things. So let me actually cd into a temporary directory. So make temp. And then I will make a malicious script, vim malicious script.sh, bin/bash. And then it'll just type hi forever. And then if I FTP back in, anonymous with no password, then I should be able to put that file in. Oh, could not create. This might have been after I uploaded it, but well, interesting.
We're trying to put or get.
Put. I might have actually changed the config in order before I did this. Non enables yes, local enables yes, right enables yes. Oh, weird. Not connected.
User.
Enter. Put.
Who's the owner of the folder?
Oh, that might be it. Well, anyway, I think there's probably an issue with file.
See if you can stage mod.
I forgot where it even is. By default, is it in the config file? Var run vsftpd. well, whatever. It's not super relevant. Either way, we see that there's like this malicious setting that's in this config file that we need to remedy. And so once you notice something like that in any config file that's running on the system, for any service that's running on the system, you'll want to go ahead and edit that config file. So we can open it in whatever text editor we like, pinpoint all of those poorly configured lines. All of them had anonymous, I believe, so like anonymous upload enable should be no. We can set the make directory write enable to no, and there was one more, I believe, anonymous enable, yeah, which we also want to set to no. And then once we've made any changes, generally with most services, you have to actually explicitly restart those services in order for the changes to reflect. So I would have to run systemctl restart vsftpd, and then once you hit enter, the service will restart, and then you'll be able to continue on. SSH also has a config file that you can check out. So the way I'm getting all these services is also get from last lecture. We showed that you can run ss-plnt or plntu if you want to include UDP ports, but it'll list all of the active ports that are running on your computer. If you include T, it'll do TCP ports. If you do U, it'll do UDP ports. If you do both, it'll show you both. And so we have that column on the left side here. We can see that we have SSH on the system. We had this mysterious XM4 thing that I have no idea why it's there, but we could look into that later if we have time. And then we have VSFTPD. So SSH also has a config file that we can check out. This one is in etc/SSH. You can just hit tab and then you'll see that there's this whole directory for SSH. The main directory that controls the daemon for SSH is SSHD. A daemon for Linux programs is the service that starts the rest of the service. So it's like the initialization of the service. It runs in the background. And so we call moving a process to the background daemonizing that process. SSHD is the daemon that runs SSH. So we have this config file called sshd_config, and we can edit this as well. So I was testing this. That's why we're at this line right here. But SSH has this submodule called SFTP. You can probably see it sounds kind of familiar, right? FTP is in the name. SFTP is the secure file transfer protocol. So it's doing file transfers over SSH. And we can use this in order to transfer files to the system. However, if we comment this line out, then we expect that we would not be able to do that. So again, let me just try this. So I have this malicious script. I can try SCPing it as root. Let's see, I'll use the SCP command to do this secure copy. And I want to transfer my malicious script file to root at 10.0.3.38, I believe was the IP, yeah, into the home directory. And now, if I go to my home directory, I'll see that that script is there. Let me remove the script just so we know it's no longer there. And then if I try editing the SSH config and then commenting this out and see if there's any other mentions of SFTP or file share, no, okay. So I believe this means that we can, if we run systemctl restart sshd, now if we try to SCP this file over, it says connection closed, subsystem request failed on channel 0. So we're able to change this config file and prevent it from doing something. So in this case, SFTP is not malicious. This is more of a demo, but SFTP requires a form of authentication. And in this case, I have my public key on that system, which is why I'm able to do this without having to put in any password. But this is just demonstrating that you can edit the SSH config and the changes reflect. So yeah, I'm not too sure what was up with the FTP example, but from before, why we were not able to edit, but it probably was just a permission thing. So yeah. But like I said, this isn't a malicious setting, so we can go ahead and uncomment that safely. But there's one thing that I do want to emphasize, and it's that whenever you have any services and you're editing config files, you have to be very careful to not have any typos. Case in point, let's try SSHing into Jordan at this computer. And now I'm logged in. And I can ls, I can cd, I can make a directory and all that cool stuff that I can do in any type of shell. Let's suppose I wanted to do that change right now. Like I wanted to disable SFTP. But then instead of typing a hash, I type like @ or something. And then I restart SSH. It says SSH failed and the process exited. So it was not able to successfully restart SSH. We can check the status to see how it's running, and we see that it failed to start the SSH server. And so essentially we just have SSH not running. Currently we still have a session in here, but if I tried reconnecting, then it'll say that we're no longer able to connect. So if you create like a misconfig in SSH, then you've essentially locked yourself out of reconnecting via SSH. Like you've created a typo, SSH will not be able to parse the file, and so you've restarted it with a typo, and therefore it causes an error. And you can't get back into the box. The remedy for this is that a lot of services on a lot of systems will have a test command. So you can type sshd-t, and it'll tell you what lines in the file are wrong. So if I type sshd-t, then it goes ahead and gives us an error for saying that there's this typo at line 117.
The call was about this room, right?
Yeah, it was about this. Yeah, the same error.
Same thing, different day.
So it gives us an error about how we can, this line is incorrect. So we can go ahead and just comment it, fix it to the way it should be. And then now if we run restart SSHD, we don't get an error. We can check the status, and we can see that it's active and running. And we can SSH in, and it works fine after I type in my password. Idea I'm trying to get at is that whenever you make any changes to a config file, in order to guarantee that you don't have service downtime, always run the test command for whatever service it might be. Some services don't have test commands, like vsftpd doesn't have one, and that's because I wouldn't know the exact reason for that, but my assumption is if FTP is down for a little bit, that's not like a huge concern because FTP isn't the method for configuring a system, and it's not something that end users will necessarily like rely on at all times. So it's a little less urgent for FTP, but lots of servers like SSH, which is critical for configuring a system, will have a test command so that it guarantees that if there's any misconfigs, then they're identified immediately, and you can fix them before you log out, because when you try to log back in, it won't work. And in addition to that, a lot of web servers and a lot of applications like that will also have a test command for making sure that the config file is all good before you try to restart the service. Otherwise, it won't be able to restart successfully. Okay. And I do encourage you to Google. So like, for example, if I didn't know what the test command for SSH was, then I could just look SSH test config file command. And I imagine that even the AI will probably give me something. Yeah, sshd-t. Probably it's in there as well for all of these links. But yeah. Okay. That's about all I wanted to say about config files. Whenever you're given an assignment and you don't know what's on the system, you should run ss-plnt to see what network services are there. And then we showed this last class. You can do systemctl list units --state equals active to see the active systemctl services. And so you will be able to see SSH in here somewhere. You can see FTP is here. What else? I imagine SSH, yeah, SSH.service is here. Yeah. So all of these services can be viewed. So when you're given a system, like you're in the homework assignment, you can run these commands in order to find out what's running on the system, and then you can inspect the config files to see what's going on with them. And if you don't know where the config files are for a given service, again, that's something you can Google. Yeah. So there's a few main components of Linux that we've already talked about. IP tables we went over last week and in the video over the weekend. And then there's two other main components that I'd like to touch on briefly. One is cron, or systemd timer. These are both two different modules of Linux that will allow you to run tasks at set intervals. So systemd timer is kind of the more new version of this. It runs under systemd, which we've talked about is like this big suite that does a lot of like service management tasks. Cron is the legacy system that does the same job. It still exists on probably all Linux systems, or more or less all of them, but it's getting phased out slowly. If you have a Mac, it'll also probably have cron on it, although again, they might have been phased out in favor of some other newer system. But it still exists, and it's still something that we should talk about. PAM is the portable authentication modules, and it's what handles the authentication system, the authentication framework for services on a system. Let's first touch on cron. We've talked about this. We talked about it just now. Jason was going over it with respect to homework 4. We can type cron tab -L in order to list our current cron tabs, and I meant to clean that up. Okay, well anyway. And then we also have cron tab -E in order to edit our cron tab. We have 2 users who are currently logged in. Right now I'm on root on this shell, and then on this shell over here I'm logged in as Jordan. I can type cron tab -L here, and you can see that there's no cron tab for me. So whereas for root I had all of this in my cron tab, I had this line over here. All of this is comments, but this is the actual thing I have in cron tab. And then for Jordan I have nothing. And I can type cron tab -L or cron tab -E in order to edit my cron tab and get something in there. So I meant to delete this, but I had this command in here which says we can see the command says run the ID command and then append it to the end of mnt/the IDs, so mount/ID IDs. And then we have this string over here which specifies how frequently this task will be run. There's this website called crontab.guru. Let's see.
I just had a blue screen of gap. That's a big issue.
You can paste in this string here.
Getting picked up, but it's still not visible.
I'm just going to check this one more time.
And we can see that it translates in English to run this once every minute. Did the screen recording cut out?
Yes.
Okay, one sec.
This is really unusual. This is the first time I've seen like this kind of
That temperamental.
like every
Okay.
like
Should be back?
one of these.
Okay, so
interfaces.
we're able
They
to
want
use this syntax in order to
I'm going to try it now.
let's see. Let's continue on the lecture. So we have this in our cron tab, which says we're running this command once every minute. Feel free to use this as a resource if you're ever configuring cron jobs. And let's just check what's in this file, because I guess I never really, I meant to clear it before the lecture, but. What, really? Okay, so what was I even doing? Let's check what's in this file. So let me do cat, or let me less it, because I imagine, never mind, I'm gonna view it, /mnt/IDs. And yeah, we have this like a bunch of lines that are just outputting the ID of this system. I'm gonna remove this file just so it's cleared. And then we're gonna add the same cron tab onto this system. So right now I have this syntax which is *-1, which means once every minute. If I wanted to do it once every 5 minutes, I could do */5. But */1 is kind of redundant. If you just do star by itself, it'll also still mean once every minute. So I'm just going to put this in and have the same command going. Star. Is that enough? ID, yeah. Put it into /IDs. I think I need to first make that file and then make sure it has the permissions so that everyone can edit it. And now at the top of the minute, which will be happening soon, we should see 2 lines go into this file. So yeah, we see one from root, one from Jordan, and you can see the different usernames. So these 2 users have their own cron tabs, and they're both running these commands that are in the cron tab as their own user. And so if you're root, then you have permission to run commands that will identify yourself as root. If you are a different user, then your commands will identify yourself as that user. And so if you have a cron tab that is on the root system, that's on the root user, then it has a lot more privilege than the things that are being run on a normal user's cron tab. We have about 10 minutes left. I will quickly go over PAM, and then we can get into some of the incident response stuff. So let's go ahead and sure. Oh, I need to fix this. Okay. Okay, so let's talk about PAM real quick. PAM is, again, the authentication backend for Linux systems. So if I go to cd/etc/pam, everything in PAM is stored in pam.d. So the .d refers to directory. So this is the directory for PAM configs. I can type ls in here, and you can see that there's a bunch of files. We have this common auth, common password, and we can see that there's also individual files for individual services. So let me just rerun it so it gets cut properly. BSFTPD has one, sudo has one, yeah, change shell has one. A lot of commands have their own PAM files so that they can specify how they handle authentication. So for example, let's take a look at sudo. I'm going to do it as a view so I don't accidentally edit something. We can see that, okay, it says required, which means that this module that it calls here is required for authentication, and it calls PAM limits.so. SO is a shared object, so it's standardized across Linux, so you can look at the, I think it should be in man. Oh, maybe not. Some of them are in man, I believe. Let's take a look at common auth. So common auth is what's used in a lot of services that require just the default authentication so authenticating via user accounts. And we can see what's in here. So it says, the first line says to use pam underscore unix dot shared library or shared object. And it says over here, this is for auth, and success equals 1, default equals ignore. So this equals 1 means that if this module succeeds, like if you're able to log in as a user, then skip the next line. So the equals 1 says what the next line is to skip. So or the number of lines to skip. So in this case, it says to skip 1, which means that we're skipping the deny. Whereas if we fail on this line, then we'll go straight to the deny, so that it'll lock us out. These .so files refer to different types of actions. So the pam underscore unix.so file would be for authenticating via a user account. And we can go ahead and try this. There's this command called pam tester that will allow you to do that. Let's see, pam tester -v common auth pam common auth. We can, and then we would put in the root, put in the user that we want to log in as. The -v means verbose. I think it should be lowercase v. And then type authenticate to determine the action. And then it just allows you to test logging in. And if I remember the password, then it says authentication failure. I guess I did not remember the password. There we go, successfully authenticated, because now I remember it. -v means verbose, so that means that it's going to put more logging messages out. So it just makes it easier to see what's going on. And we can try editing this. You should not normally do this, but we can try editing the common auth file to see what's going on. So for example, I said that if you set e equal to 1, then it'll skip the next line. But if I set it equal to 0, then it'll go straight into the deny. So now if I try running this pam tester command and use the correct password, it'll stall, and then it'll say permission denied. So we're able to edit these modules to do different kinds of things. This would be a very bad case if you accidentally logged out of SSH with success set to 0, because it means that whenever you try logging back in, you'll always be logged out. And you can notice that I didn't do systemctl restart for PAM. PAM does not run via systemctl. I believe it doesn't run as a service that like relies on the config on each boot up. These configs are all called at runtime. And so if you have made a change to these configs, they take effect immediately. So for example, I have success set equal to 0 right now, and I didn't run relog in, and we were able to run pam tester, and it immediately showed that I wasn't able to log in. If I try SSHing as Jordan and try to log in, we can see that the same error has happened even though I'm typing in the correct password. And so that the change in that one PAM module impacted everything. We're logging in via SSH right now, which means that we're technically using that SSH PAM module that we saw earlier. But most PAM modules will end up calling common auth at the end of the day. So like they'll have a bunch of lines, but one of those lines will be calling common auth, because common auth is what's used for authenticating via user accounts, which is what SSH does. Okay, let me set this back to 1 so that I can log in later. And now I should be able to log in fine. Hopefully, yep, okay, cool. Okay, only a little bit of time left. Let's go circle back a little bit. We talked briefly about logs last lecture. We were talking about how these are used in incident response. So if you have a vulnerable service, you want to make sure that any vulnerabilities get put into logs. I say you have a vulnerable service. Essentially, all services are vulnerable in one way or another, and we just don't know how. So we want to make sure that all actions are being logged. The nice thing is that a lot of services will do this by default to some extent. You can configure the depth of the logs, but they'll all have different capabilities of logging. So, for example, I can run journal ctl -u SSH, and it'll show me SSH logs. We can see that there was a failed password authentication attempt that we just had from just now. And if I want to generate more of those, let me try sudo lxc attach into this other VM that I have, this other container that I have. I'm going to use this tool called Hydra in order to just brute force trying to log in as root on this system. So I'm going to use hydra-l root-p. This -l means login as root, and then -p is giving the word list. I'm using rocku.txt, which is a pretty standard word list for passwords. And then I'm going to put in the IP address, which should be this. And I'm glad I've plugged in my charger, because this is going to like kill my battery, I imagine. So now I think it's running. It's going to be trying to brute force against this root user. And now if we check the logs, we can see that there's a bunch of logs, and there'll be even more pretty soon. So it's just a bunch of failed login attempts. If you're a system administrator and you see that going on, then you have like an alarm going off in your head, because you know something is going wrong. Someone's trying to attack. The logs like this are like a very bad sign, essentially. And so it's a good thing to, 1, be checking logs frequently, and 2, like have a good eye out to see what are potentially malicious traffic. And when you see something like this, you always want to reflect on it and see what you can learn in order to improve your security posture. So the main thing that you could take away from this is to install some kind of like dynamic agent that, agent is the wrong word, some dynamic service that will lock people out if they try to have this many failed login attempts. There's this service called fail2ban, which I guess I won't have time to demo, but it's not a huge deal. This isn't relevant for any of the assignments necessarily. But it's a service that can run and ban hosts that have frequent failed authentication attempts. So if fail2ban will run in the background, and it'll monitor the SSH logs. And if it sees that there's this one specific IP address that's causing a bunch of authentication failures, which is this specific IP address over here, then it'll just lock that user out. Like it'll block them from accessing your network for some amount of time. Fail2ban is the service you use for that. So whenever you find something like going wrong in logs, you always want to find a way to make sure that the problem that caused those logs is no longer there. And fail2ban would be one method for that. Real quick, I'm going to just show this, I guess. I guess we can talk about it at the beginning of next lecture as well. Did I update this? Yes. There's this vulnerability scoring system called the CVSS. We've talked a little bit about CVEs. Do you remember what it stands for?
Common vulnerabilities and exposure.
Common vulnerabilities and exposure. It's a standardized system for keeping track of different types of vulnerabilities.
When you were seeing the exploits, the kernel vulnerabilities, you saw like a CVE-year-blah blah blah, right?
So this is the scoring system that is used in order to like evaluate the severity of different types of vulnerabilities. It operates in the same way of like earthquake like severity scales, like it's a scale from 1 to 10 essentially, more so, something like that. And whenever let's talk about this more on Thursday, yeah. I think. But you're able to evaluate the severity of a vulnerability. So we're over time. We can talk about this on Thursday.
Just click all of them and see what the highest number you can get. I think it's network is the highest.
Oh yeah, true. Scope, I have no idea.
Yeah, change, high.
Oh, 7.6. That's not as high.
Privilege required.
Oh,
attack
none.
complexity low.
User interaction
None.
none.
Attack complexity low.
10. Oh, okay. You're pwned. This would be like 30 frag or something. I don't
No.
idea. I don't have no idea actually. All right, let's just end there.
All right. See you on Thursday.